is 2187. The minimum time to complete trips, right? So the question saying that you have given an array time, right? Time array, and time of I means each element of you can say time is time of I, right? That denotes the time taken by ith bus to complete the one trip. Okay, so each bus can make multiple trips successfully, that is the next trip can start immediately after the completing the current trip, right? And also each bus complete independently, that is the trip of one bus do not influence the trip of any other bus, right? And you have given an array total, you have given an integer total trip, right? And trips which denotes the number of trips and all the buses should make in total, right? And we have to return the minimum time required for all the buses to complete at least total trip, right? Let's assume that we have given this example 1 and time we have given is 1 2 3, right? And total trip we have given is what, 5. So if we will represent this in array form, it look like this one, and total trip we have is 5 we have given, right? So when at time, right, let's suppose t equal to 1, right? So at t equal to 1, how many buses we have, right? How many trips we have to do this, right? So we have 1 2 and 3, right? So if we'll talk about this one, so for the t equal to 1, I'll suppose that t equal to 1 is how the bus are completed, these trips are number of trips completed by each bus are let's suppose 1 0 and 0. Okay, so initially when t equal to 1, we can say t equal to 1, right? So time at I equal to t equal to 1, and we can say when at time t equal to 1, this is the trip we have. If we'll do this sum, it will become 1. Okay, if we consider t equal to 2, right? So in this case this will increase, right? And it will become what, trip 1 will get added to here. Let's suppose this will become 2 now. Now trip 2 we have started, like we are doing what, 0 1 and 2, right? So trip at t equal to 2, it become 1, 2 is become 1 become 2 and 0 become 1, and this will remain same, right? So if you do the sum, right, you will find that a total trip is now 3, correct? 2 plus 1 is 3. Now when t equal to 3, right, at this time what will happen, now 2 is become, right, how many trips it become 3 now. Now 1 will let's suppose we will leave it 1, right? Because see, the total trip is 5, right? And we have already completed 3 trips now, so only 2 trip is remaining. So one trip is completed, this one, another trip is completed here. Okay, so if we'll do this sum, it will become what, total 5 trip is required, right? So in this case you can see that minimum trip is required for all the buses to complete at least is 5, right? But minimum is 3 we have, right? Minimum trip we have to require is 3 in this case, and that's why we have to return output equal to 3. Okay, let's assume the another example in which we have given t time at this one is only 2, right? So when total trip is only 1, so minimum 2 trip is required, right, to complete the t equal to 1, right? So there is only one bus we have, and it will complete its first trip at t equal to 2, right? Because the minimum time required to complete trip 1 is 2, right? That is we have here. So if we'll talk about the constant time length will be become what, time dot length is greater than equal to 1, and it should be less than equal to 10 to the power 5, and t of I and total trips is greater than equal to 1, you can say, and less than equal to 10 to the power 7, right? So this question has been asked in Google and Amazon, so this question is very important for us to do, right? So let's assume that if you have already completed this one, right? So there is other questions that you can do, that maximum candidate allocated to k children, minimum speed to arrive on time, minimize maximum of the product distributed to any store, maximum running time of n computers, maximum number of robots within the budget, and minimum minimum and maximum of the array, right? These questions you can do after completing this one, if you have already completed, or if you want to complete after this one, then you can do more hands-on, right? So you can find this on Leetcode, or if you not able to find the links, you can put me here that you need these links, right? I'll provide that one. So two hints we have given in this question, that is you can use either binary tree, or for a given amount of given amount of time, right? How we can count the total number of trips completed by all buses within the time, right? Within that time. So that hints we have given, right? How can we count the total number of trips completed by all buses, right, within that time? So let's assume that in this problem we are given a array time representing some buses, right? So let's suppose that time we have considered that this is 1 2 3 1, right? So for the ith bus, let's suppose this is the ith, right? And for the ith bus, right, needs time at what, this I, right, you can say. So time at I, let's suppose I equal to what, 0, then we will take this one, right? Time at I, this one is 1, right? So to complete this trip, each bus works independently and doesn't need breaks between the trip, right? So we have to take this example, because when we have given these 4 buses, right, and total trip we have given is 10, right? Then how we will implement this one, right? So assume that at this time the time needed is the given time. Let's suppose we have some given time. Let's suppose given time we have given, right? So at this given time for bus I, okay, for bus I, let's suppose what we will do, the number of trips it can finish within the range is what, total time we have. So the total the given time we have, right? And then we will divide by time at what, I, whatever the value will have, that one, right? So the number of trips, this is the number of trips will become the given time, and then time at I, right, the element. So thus the total number of trips is the sum of this one. If you will do the sum, then for all the buses, right, for all the buses if you'll do, then we will get what, the sum, total number of trips we will get. So what we can do, we will if we'll say we have given t equal to 1, t equal to 2, t equal to 3, t equal to 1, and total trips we have given like this. So if we will represent after this, applying this formula, time given by this one, so what will happen, total time we have given is 6, right? So 6 by 1 it will convert 6, total trip is 6 we have. And if we'll talk about t equal to 2, right, so total trip is now what, 3, 6 by 2 is 3, and 6 by 3 is 2, and similarly 6 by 5 is 1, right? So if you'll do the sum, right, so number of if you'll do this sum, right, 6 5 6 3 2 1, and it will become what, sorry, so it will become what, total trip become what, 12, right? So you have seen that how we will find the total trips, right, number of total trips you can say, right? So what we will do, we have to find the what, minimum trip, minimum time for all the buses to finish total trip. So total trip we have is we have given is what, 10, right? Total trip we have given is 10, right? And we have to find and number of trips we have is 16, right? So to find for the given total trips we have 10, right? So for the 10 trips, what is the minimum time for all the buses to finish, right? That we have to 10, right? So we have given 10, right? 10 total trip we have to do 10, right, here. But we have we can do what, by this example we can do what, 12 trips, right, number of trips. So how we will complete this, total trip is 10 equal to total trip is equal to 10, and what is the minimum time we have to find for all the buses to finish, right? I think you have understood. If not, please pause and go back to understand this whole concept again, and so that you will understand the approach that we are going to discuss, that is the binary search, right? So we are going to see the binary search approach, in which we will see that how we will use the brute force approach, right? And since we are asked to find the minimum valid time to finish the total trip, right, and it is safe to check, right, each time that is starting from the smaller, right, and if you can say smallest, you can say, right, and it is safe to check the time starting from the smallest, right? So if the current time is not enough, right, we will move to current plus what, 1, like see if the time is enough, right? If time is enough, we can say time plus 1 is also enough, right? And if time is not enough, means t minus 1 is not enough, right? So it is saying that what we will do, if the current time is not enough, we will move to current plus 1 time, right? So if we keep trying each time until we find the first and the minimum time that is long enough for all the buses to finish total trip, correct? We will try to do that first. Okay, we will keep trying each time. What we will keep trying each time, and we until we will keep trying to find each time until we find the first time the minimum, you can say a minimum time that is for long enough for all the buses to finish the total trip, right? So you can say for the total time to total trip, right, to finish total trip, right, we will try to find the total trip within the minimum time, right? We will try to find, okay, for all the buses to finish the total trip, you can say. However, according to the constant, right, according to the constant, right, that we have given us in this question, right, we can afford to try every time from the smallest, as this approach is likely to exceed the time limit, right? So we shall look for the better way to locate the minimum time, you can say. So after some observations, right, what we will observe that time t is enough, right? So t plus 1 is also enough, correct? And if t isn't enough, means t minus 1 isn't enough. Okay, I think you understand, right? So what we are trying to say that, like, we will try to start with the brute force approach, right? And we will find the minimum valid time to finish the total trip, right? And so what we will do, we will check each time starting from the smallest. Okay, so if the current time is not enough, we will move to the current time plus 1. Okay, and we will keep trying each time until we find the first and the minimum time that is long enough for all the buses to finish the total trip. Got it? So what we will do, let's suppose let's understand here. So what we will do, combining the two patterns, right, we have found before that whether each time is long enough to finish the total trip or is not shown in the figure, like this one. Okay, so we will need to find the boundaries which is minimum valid, right? So can we find the total trip of the given time, right? So there will be some pattern, right? We cannot find here, but we can find here, right? So our task is to find this boundary, right? So rather than the brute force, what we can take the advantage of this feature and use the binary search to cut the search space by half each time to locate the minimum valid time. Okay, so we have to take the advantage of this feature. Okay, and we will find our task. We have to find the boundary, and then we will search, we will do the binary search, and we will cut the binary space by half so that we can locate the minimum time valid. Okay, so we will start initializing the each space, and we set the boundary as left equal to 1. Okay, and since it is a minimum possible time, we also set the right boundary as right equal to total trip plus maximum time, right? You can, what I am trying to say here, let's suppose we will if we set the boundary left equal to what, left equal to 1, since it's the minimum possible valid time, so we also set the right boundary. Okay, so the right boundary is what it will become, we have given, let's suppose total trips we have given. Okay, so in the total trips, what we will do, we will multiply the maximum time, we will do multiply, okay, to get the you can say right boundary. So left boundary and right boundary we have to set. Okay, so I was saying, like, what we will do, we'll try to use the binary search, and we'll cut the search space by half each time, and we will locate the minimum valid time. So starting with the initializing the search space, right, we set the left boundary as left equal to 1, like this, right? And since it's a minimum possible valid time, so we also set the right boundary as right equal to total trips into maximum time, whether maximum time is what, equal to the maximum time taken by one trip. Okay, so it will get updated instead, right? So the right is guaranteed to be long enough. Okay, so therefore the minimum time is included in this search space. Okay, so then we keep checking if the middle time is long enough, right? So if it's not mid in the too short, we shall cut the half containing a smaller times, and otherwise we shall cut the half containing larger time, right? Then we will move on to the remaining half, and we will repeat until there is only one time left, which is minimum valid time. So we check if the time given time mid is sufficient by iterating over the input using the formula. Will mid by time I, right? What we will do, we'll say the mid by time of I. Okay, so what we will do, so we'll check the middle time, right? This mid time, we'll check the mid time if this is long enough, right? So if it is not mid is not too short, right, then what we will do, we shall cut this half containing smaller times, right? Otherwise we shall cut the half containing larger times, right? And then we will move to the remaining half, and we will repeat this process until there is only one time left, where is the minimum valid time we will get. And when we check if the minimum time is sufficient for iterating, right, over the input using this formula, then we will say what mid by time we will do, and we will apply this one. Okay, so what we will do, let's go to the browser section and we will try to implement this one. Okay, we have given two things. First, time we have given and total trips we have given. Okay, so time we have given is integer array, and total trips we have given, right, as per our requirement, right? So what we will do, we will first try to find the boundaries, right? The left boundary and the right boundaries we will try to find, right? So if we'll talk about the maximum time, we'll take some max and we'll say time. So this is our max. Let's suppose this is our max time, right? So we have max time, and in the max time we'll put 0. Okay, and we'll try to find the maximum time between the array, given array, right? So what we will do, we'll make a loop of the you can say over the time, right? So this is integer time, this is time. We can take t and write from the time, right? And then over the time, what we will do, we'll make a loop. We are going to make the loop and we'll find the max time, right? This is our max time. So we'll we will do max time equal to, we have math dot max, right? So we'll take math dot max, right? This function will apply this one, and will pass was the max we have, right? Max time we have already, right? And then we will check with the all the times one by one, and we will update our max time. Now you have max time, right? So now what we have to do, we have to define your left and right boundaries. So let's suppose I'll take long as a time because return type is long. So I'll take long, and this is our left. Okay, so we'll start with left is what 1, as we have discussed, and then we will use long right, suppose. So right is nothing but we'll take the maximum time we have, maximum time we have talked about already, maximum time, and divide by will use what into, right? We'll into we'll use into total trip, right? And we have given total trip we have given above, right? This one. So we got our left and right, right? So what we will do, we'll try to find this one. Okay, so here in total trip is given is integer, and maximum time is also in integer. So what we should do, we should typecast this one using the, you can say, a long one. So I'll pass this one, so we will typecast this one. Okay, once we have the boundaries, we got our boundaries, we'll do the binary search. You can create one other function for the binary search, and you can apply here, or either what we will do, we can say let's find the minimum time, right? So find the mean time, right, to finish all the trip. Okay, total trip, to find the total to finish the total trips. Okay, now what we will do, we'll make a while loop, right, and we'll say if the left is less than what, right. If left is less than right, then what we will do, we'll find our mid, right. So let's suppose mid we have, right, is left plus right, left plus right, and that by 2 you can say. So we should take into this one for the safe purpose. Okay, now we'll got our mid, right. So once mid is ready, right, now we'll check the enough time, right. So equals long enough you can say, right. So if we should make one function, right. So let's suppose we'll create the function like long enough we can take, right, long enough, yeah, enough, or you can say enough time you can also say. Okay, so we will get our long enough, right, and we'll pass this long enough two things, right. First we will pass the given time, right, array, then we will pass our mid, and another we will pass our total trip that we have, right. Three things we should pass, right. So it will return enough, right, long enough we have, yeah, time enough time we have, right. So I'll give enough time is better name, enough time, right. Now we have, and this is the method, so I'll pass in the smaller case, right. Now what we'll do, so long enough or time enough we can say, we'll say if we have the time, so I'll update our mid from right is at mid. If not, if that is not the case, then what we will do, we'll update our left, and left should start with mid plus 1, as we know the binary search thing, right. So this is nothing but our you can say binary search, this is just if you are aware with the binary, this is binary search. Okay, once this is done, right, now our loop is completed, then we should return, as we discussed, left, right, the left boundary we will return. Now we have created already the enough time function we have to create, that we are checking, right. So to do that, this will return what, boolean, true or false. So I'll pass this one, and the things that we are passing, right, the first was int time, another was what, a long given time, given you can say time, and another was what we have is total trip, right. So I'll pass int total trips. Okay, like this. So we should pass in total trips capital, or you can say take like this. Okay, total trips. Now this is done. Now what we will do, we'll check the actual trips, right. So we'll find one, take actual underscore trip, and this is nothing but our 0. Okay, so we will start the actual trip, and then we'll try to find this, right. So what we will do for all the time, right, what we will do, we'll check int, and that's nothing but a time, and we'll start from, we will get from the time loop, right. We'll check on the time, and we'll try to find the actual, right. So actual trip we will have is we can get, right, from what, given time we have, right. So we have given time, so given time, why I have told you time, right. So we have the time element, time at I, time of I, and we'll do plus, right. Each time we will do plus, we'll do the sum, right, for at each time, and if that is the case, right, so we will return each time what, actual trip we have, right. So we'll check if actual trip is greater than and equal to, right, total trip, if it is greater than equal to total trips, so it should return this one. Okay, like this. Let me what we should do, we should compile this one. So it is working. Yeah, it's working. Thank you. So what we will do, let's understand the complexity, right? So what we have did here, first let's summarize this one. We have given time and total trips, right? So what we will do, first of all we will find the max time, right? So to find the max time, what we will do, from on the array, right, we will check which one is max, right? We in on the array time array, what we have, 1 2 3 4 5, right? Let's suppose we have, so 5 will become into the max time. Okay, then what we will do, we'll start the left and right boundaries, we'll find the left and right boundaries, and we'll do the binary search, and we'll try to find our mid. If it is time is enough, right, what we will do, we'll do right equal to mid, right will come onto the mid, and the right part we will discard. And if not enough time, then we will consider the left part, and we'll say left is at mid plus 1, and we'll discard the left part, right? And finally we will return the left. Now consider this one, how we'll find the enough time. So on the enough time, we'll on the time we'll check actual trip is what, plus equal to given time. We have some we have given time, right? So we are passing the long enough, we are passing time, mid and total. So each time we are passing mid, so mid is nothing but our given time. So at that given time, we'll check the given time by t will do, and we'll find our actual trips, right? So if actual trip is greater than equal to the total trips, right, we'll say this is our you can say we have enough time, right? And we'll update our you can say right and left boundaries. Once this is done, then we will return our left. So if you notice that, let's assume that the time we have given is of length n. Okay, and the upper boundaries for this total trip is m. Okay, so what we will do, if we'll find k as the maximum time taken by one trip, or suppose that we are talking about this one, let's suppose this is a k is maximum time. Okay, so what we will do in that case, we are going for all the time, right? So time complexity will talk about tc, it will become what, o of the n, we have n into will do the log of what, we can say m is m into k, and m is upper limit of the total trip, right? M is the upper limit of total trip, and k is the you can say maximum time taken by the one trip, right? Will do. And if we'll talk about the space complexity, right, so we are not taking any extra space, and that's why we say O of 1 as a constant type, right? So here if we'll talk about the n is what, n is you can say time length, right? Time array length, time. Okay, and m we are talking about is total trip. Okay, total trip upper limit, like upper limit value. Okay, and k is you can say maximum time, max time of a trip, okay, of one of the trip, you can say. Okay, so this is we have for the today. If you like this video, please hit subscribe, so that you will get more videos like this, and it will encourage me to help you in the future. And to grow this channel, you should hit subscribe and like this video. Thank you so much, guys. Thank you so much for your love. Thank you so much.